Unit 4 from Jan 2019. Propanol react with iodine in acidic condition. Which method could not be suited or would not be suitable for obtaining the rate or the speed of this reaction? So calorimeter can be used because iodine to turn to iodine. Measuring the pH of a solution. So to identify the pH of a solution or measuring a pH of a solution, so because the reaction here, as you can see, this reaction is producing the hydrogen ions, H plus ions are there, which are produced. So means that is also suitable. Measuring the increase in infrared absorption of CI and quenching followed by titration with sodium thiosulfate. So sodium thiosulfate, this can be used because iodine is there. So we quench an iodine to identify, but measuring the increase in infrared absorption of CI bond, if there is a CI bond, there will be no like increase or decrease. Even if one molecule is produced or 100 molecules are produced, they will all absorb the same amount of infrared radiation. It does not make difference to absorption of the infrared radiation. Like if I have one molecule which is having CI, I have 100 molecules which are having CI. So infrared absorption will be same because it is the wavelength, the range of a wavelength or a wave number which we get. It does not show the number of the molecules. So measuring the increase in infrared absorption cannot be used for this because there will be no increase. Like suddenly reactant form a product, even one molecule is formed or 100 molecules are formed, but the amount of infrared absorption energy won't change. Like the wave number does not change. Then the second question for the reaction, hydrogen, mercury chloride is there, C2O4, give 2Cl plus CO2 plus mercury chloride. The concentration of this is first order with respect to mercury chloride and second order with respect to C2O4. So the question is, the concentration of both HgCl increases by factor 3. So if we increase this by factor, so rate is proportional to, this is first order with respect to HgCl. So if this is double, this is 3 times. So this will also be 3. But for rate proportional to, according to rate equation, rate proportional to the concentration of C2O4 square. So if this is multiplied by 3, 3 square is 9. So this will increase by 9. Because if this is 3 times, square of 3 is 9. So due to change is this 3 times and 9 multiplied by 3, 27. So D will be the right answer for this. The next question, to determine the activation energy for a reaction, graph was plotted between ln k and 1 over t, where k is the rate constant. What is the gradient? So when we compare with the equation of straight line, y is equals to mx plus c. On y-axis, if I have ln k, on x-axis, if I have 1 over t, so what will the gradient of this graph? The gradient will be equal to minus EA over R. So minus E over R, so B will be the right answer. Because this gradient, what we are left with, so that is minus EA divided by R. Then which is a correct standard molar entropy, like highest, medium, and lowest? So as number of the particle increase and in the gaseous state, the entropy will also increase. In a solid, the entropy will be minimum. So iron is a metal, metals are solid. So iron will have the minimum entropy, and nitrogen is a gas, and hydrogen is also a gas. But how we identify which one Because when you see nitrogen is N2, hydrogen is H2. But nitrogen contain more particles, like nitrogen contain, each nitrogen is having 7 electrons, so their total will be 14 electrons, whereas hydrogen only 2 electrons. So few particle, less entropy, more particles, greater entropy. If we have same number of atoms, then we check the number of particles. Then for a Haber's process is used to make nitrogen at 450 when the temperature of a system increase. Kp or Kc does not depends on the temperature. Sorry, Kc or Kp does not depend on change in concentration. Temperature dependent is there. So when the temperature in the system is increased, so what will happen, because the reaction is exothermic? So exothermic reactants will have high energy and the product will have low energy. So N2 will have N2, 3H2 will have high energy and 2NH3 will have low energy. So where the equilibrium or the balance will shift if I increase the temperature, reversible reaction, so it will shift backward. As a result, it shift backward, so percentage of a product, or because Kp will be the product divided by reactant. Kp, Kc is product divided by reactant. So if the amount of product is decreasing and amount of reactant is increasing, what happened to value of a Kp? The value of a Kp will decrease. So A will be the right answer. Changing the amount of reactant and product does not affect the Kc or Kp, only change in temperature. Is it clear, this question? When magnesium hydroxide dissolves, what should be the expression? Whenever they ask for expression, you have to check whether it is a homogeneous or heterogeneous. Solid, aqueous, and aqueous. So it is heterogeneous. For heterogeneous, we don't include solid, liquid. We only include gas and aqueous. So when we write the formula for Kc or Kp, that is product divided by reactant. So product is magnesium hydroxide and the reactant is magnesium hydroxide and product is magnesium ion plus hydroxide ions. So we don't write for the solid. That's why A should be the right answer. Oh, sorry, B should be the right answer. So why we did not include magnesium hydroxide? Because that is in a solid state. Energy is given out when 1 mole of a gaseous magnesium ions are hydrated. This is more exothermic than corresponding value of a barium. Like why magnesium release more energy as compared to barium when water molecules surround? Because magnesium is smaller in size, so stronger bond it will form with oxygen present in the water. As a result, more energy will be released. So ionic radius of a magnesium is less than barium. So smaller ionic radius and greater charge is same for both ions, because magnesium is +2 and barium is also +2. But because barium is larger in size, so it cannot form a very strong bond with the ion, and the oxygen cannot have a very strong attraction. That's why it will release energy, because bond forming is exothermic, but this will release less energy. So for question 7, A should be the right answer. The graph shows how the yield of a gaseous equilibrium at different temperature and pressure. So when we increase the pressure, yield increases. So it means which side we will have, because if yield is increasing, yield of a product is increasing, it means equilibrium shifted towards right hand side. So here we will have less moles and reactant will have more moles, because increase in. But when we check the temperature, increasing a temperature also increasing a yield. So it means the reaction should be endothermic, in which reactant have low energy and the product is having high energy, because both cases, increasing a pressure or increasing a temperature, increasing the yield. So it means the equilibrium has shifted towards the right. And if equilibrium shifted towards right, it means for a pressure, if to shift the equilibrium towards right, it means the less moles should be there on the right hand side. So the reaction, what kind of reaction is this? So this reaction is endothermic reaction. And how many moles on the right hand side? There are few moles, because increasing the pressure is increasing the yield as well. Is it clear, this question?